Good morning, children. In previous class we had studied the physical change and chemical change and their properties. In today's class we will learn how to write the chemical equations and how to balance the chemical equations. Okay, before going to learn the how to write the chemical equation and how to balance the chemical equation, we will know what is chemical reaction. What is chemical reaction? Okay, chemical reaction is a process or the process in which one or more substances reacts to give new substance having different properties is called chemical reaction. Okay, the process in which one or more substances reacts to give new substance having different properties is called chemical reaction. Okay, chemical reaction involves breaking and breaking of old bonds and making of new bonds. But in some of the reactions, just bonds are rearranged. Okay. This chemical reaction is characterized by changing state, change in color, change in temperature, evolution of gas and formation of new substances. Chemical reaction is characterized by change in state, change in color, change in temperature, evolution of gas and formation of new substances. Before going to learn how to write the chemical equation and how to balance the chemical equation, we will perform some activities. Okay, first activity. In first activity, magnesium ribbon is burnt in presence of oxygen. Okay, see here, this is burner tube, this is burner. Here magnesium ribbon is held with the help of pair of tongs. When magnesium ribbon is burned in presence of oxygen, it burns with white dazzling flame and it forms the white powder. this white powder is nothing but it is magnesium oxide. In this reaction, magnesium metal is converted into magnesium oxide. Okay, here before performing this activity, magnesium ribbon should be cleaned with sandpaper, because magnesium, when it is exposed to air, it forms magnesium oxide layer over the surface of magnesium ribbon. Because of the formation of this magnesium oxide layer over the surface of the magnesium ribbon, okay, magnesium metal cannot participate in the reaction. Therefore, before performing this activity, magnesium ribbon should be cleaned with sandpaper to remove the magnesium oxide layer which is formed over the surface of the magnesium ribbon. This magnesium layer acts as a barrier between the oxygen and the magnesium metal, and it will prevent the magnesium metal from participating in chemical reaction. Okay, this is first activity. Activity 2. In activity 2, lead nitrate. Lead nitrate is mixed with potassium iodide. Okay, see here. This is one test tube and this is another test tube. In this test tube, we will take lead nitrate solution. Lead nitrate solution. This solution is colorless and clear solution. Okay. In second test tube, we will take potassium iodide solution. This solution is also colorless and clear solution. Okay, now I will mix these two solutions. As a result of mixing of these two solutions, I will get yellow precipitate of lead iodide and clear solution of potassium nitrate. Okay, this clear solution which is present above this yellow precipitate. This is yellow precipitate. Actually, here it is blue in color. Okay, but actually here is solid. Yellow solid is formed. Okay, here that solid is known as precipitate. Okay, in the form of precipitate, small. Okay, solids are formed. This yellow precipitate is nothing but it is lead iodide, whereas the solution above this yellow precipitate, clear solution above this yellow precipitate, is potassium nitrate solution. Okay, this is second activity. Okay, in this activity, lead nitrate reacts with potassium iodide to form the lead iodide and potassium nitrate. Okay, we can observe that in this activity, color of the substance changes. Actually, this lead nitrate and potassium iodide are colorless, whereas when they react, they forms the new compounds, that is lead iodide and potassium nitrate. Okay, this lead iodide is yellow in color, whereas this potassium nitrate is colorless. Okay, like this, here color changes and new products are formed. Third activity, okay, this involves reaction between, in third activity, reaction between zinc granules and dilute hydrochloric acid, or even we can also take dilute sulfuric acid. Okay, we will take a conical flask. This is conical flask. In this conical flask, we will take dilute hydrochloric acid. Okay, HCl is the chemical formula of hydrochloric acid and H2SO4 is the chemical formula of dilute sulfuric acid. Okay, dilute is represented like this, DIL, dilute HCl, dilute H2SO4. Okay, in this dilute HCl, we are placing some zinc granules. Granules means small particles, small pieces of zinc. Okay, these are zinc granules. Okay, this mouth of this conical flask is closed with a rubber cork which is fitted with a tube. Okay, this rubber cork is fitted with this tube. Okay, now dilute HCl reacts with the zinc granules. As a result of reaction between these two, here hydrogen gas is released. Hydrogen gas is released. This released hydrogen gas will move upward and it will move out of this conical flask through this tube. Okay, if you bring a matchstick near this, okay, matchstick near this tube, will absorb blue colored flame. Will absorb blue colored flame. This blue colored flame indicates that inside this conical flask hydrogen gas is released. Okay, so actually this is conical flask because its base is in cone shape. Its base is cone shape, therefore this is known as conical flask. Okay, here inside this conical flask, dilute HCl is placed. Inside that dilute HCl, we are placing zinc granules. When dilute HCl reacts with the zinc granules, it releases hydrogen gas. Okay, this hydrogen gas will move upward and it will move out of this conical flask through this tube. Okay, if you bring a matchstick, okay, matchstick near this tube will absorb blue colored flame. Okay, if blue colored flame is absorbed means this indicates the liberation of hydrogen gas here. Okay, this is the third activity. Now we will try to write the chemical equations. Chemical equations for reactions which are observed in the above three activities. Okay, then before writing the chemical equations for the chemical reactions which have taken in the above three activities, let us know what is chemical equation. Okay, chemical equation is the representation of chemical reaction in the form of formula of reactants and products separated by an arrow mark. Okay, the representation of chemical reaction in the form of formulae of reactants and products separated by an arrow mark. Generally, we can also write this like this: reactants reacts to give products. Okay, this is reactant and this is product. Okay, these products are separated by arrow mark. Okay, then what is reactant? What is reactant? The substance that takes part in chemical reaction. We can also say that the initial substance that takes part in chemical reaction is known as reactant. Okay, then what is product? Okay, the final product not product, the final substance or new substance which is formed during chemical reaction. Chemical reaction is known as product. Okay, here positive sign is put between the reactants and products. If their number is more than 1. Okay, if their number is more than 1, then positive sign is put between the reactants and products. And here arrow mark points in the direction in which chemical reaction proceeds. See here arrow mark is heading, or it points in this direction because in this direction chemical reaction is proceeding. Here reactants are converting into products. To make a chemical equation more informative, physical state of the reactants and products are mentioned in the chemical equation. Okay, so if reactant or product is in liquid or if it is in gaseous or aqueous and solid. Okay, the liquid, gaseous, aqueous and solid states of reactants and products are represented by notations L, G, AQ and S. Okay, inside this we are representing liquid by letter L, gaseous state by letter G, aqueous state by AQ, solid state by S, and they are all written inside the bracket. Okay, aqueous, okay, AQ is used. It is written, AQ is written when reactant or product is present as a solution in water. Okay, when reactant and product are present as a solution in water, at that time only we have to use the AQ. Otherwise, if reactant is in liquid state, then we have to use the L notation. If it is in gaseous state, we have to use G notation. If it is in solid state, we have to use the S notation. Okay, and all these notation should be written inside the bracket. Okay, next, reaction conditions like temperature, pressure and catalyst are written above or below the arrow mark. Okay, see here, this is reactant or it gives the product P. Okay, if this reaction is taking place at temperature 850 degree Celsius, okay, then the temperature should be written above this arrow mark or below this arrow mark. Okay, this is how we have to write the chemical equations for the chemical reaction. Okay, now we will write the chemical equations for chemical reactions that have taken in above 3 activities. Okay, in activity 1 we observe that reaction between magnesium and oxygen. Okay, so magnesium ribbon, it is a solid, it reacts with the oxygen gas, it is a gas. Okay, so when these two reacts, they will form a product magnesium oxide. Okay, it is a solid. Okay, if we write the chemical equation like this, here we are writing the reactants and products in words. Okay, we are writing in the form of symbols. See here, if we write this chemical reaction like this, magnesium reacts with oxygen, it forms magnesium oxide. Okay, this is symbolic form of equation. This is word equation. Here reactants and products are written in words, therefore this equation is known as word equation. This reaction is known as word equation. But here the reactants and products, okay, they are symbolically represented, therefore this chemical equation is known as symbolic representation of chemical equation. Symbolic representation of chemical reaction. Sorry, not reaction, chemical equation. Okay, like this we have to write the chemical equation of a chemical reaction. This is one. Next we will see activity 2. In activity 2 in activity 2 reaction takes place between lead nitrate and potassium iodide to form lead iodide and potassium nitrate. Okay, see here, lead nitrate. Okay, this is aqueous equation. Okay, we have, in while performing activity I said that lead nitrate solution. Okay, since it is a solution, therefore here state of this lead nitrate is represented by AQ. It reacts with the potassium iodide. Again it is also in aqueous state. On reaction they form lead iodide. Okay, while performing activity I said that yellow precipitate of lead iodide is formed. Okay, this is yellow precipitate, therefore it is solid. Okay, along with this potassium nitrate is formed. Okay, potassium nitrate is the clear solution. It is present above this yellow precipitate. Okay, now this is the word equation for the chemical reaction between lead nitrate and potassium iodide. Next we will write symbolic representation of chemical equation. Okay, lead nitrate, lead means Pb, nitrate means NO3. Okay, this is the chemical formula of lead nitrate. Its state is aqueous state. Potassium iodide, Ki is the chemical formula of this potassium iodide. This reacts to give the lead iodide. It is a yellow precipitate and it is in solid state. Along with this potassium iodide is formed. Okay, sorry, not potassium iodide, potassium nitrate is formed. It is again in aqueous state. KNO3 is the chemical formula of potassium nitrate. Okay, this is how we have to write the chemical equation for the chemical reaction between lead nitrate and potassium iodide. Sorry, I have skipped here iodide. Okay, next one more activity. In activity 3, okay, zinc metal reacts with dilute HCl. Okay, here zinc metal, first we will write word equation. Okay, zinc metal, zinc is a solid, it reacts with the dilute HCl. Dilute HCl, hydrochloric acid, is a liquid. On reaction they form the products zinc chloride. Again it is a liquid, along with the liberation of hydrogen gas. Okay, here hydrogen gas is released. Okay, sorry, zinc metal, sorry pa, word equation. zinc, it is a solid. Dilute hydrochloric acid. They reacts to give zinc chloride. Again, this zinc chloride is liquid or aqueous, and hydrogen gas is released. It is gaseous. Its state is gaseous state. Hydrochloric acid, it is in liquid state. Next we will write symbolic chemical equation. Zinc metal reacts with dilute HCl to form zinc chloride along with the liberation of hydrogen gas. Okay, so this is the chemical equation for the chemical reaction between zinc metal and the dilute hydrochloric acid. Okay, see here hydrogen gas is released. Okay, if in chemical reaction if gas is evolved, okay, if gas is evolved, then it is represented by upward arrow mark. Okay, it is represented by upward arrow mark in chemical equation. If precipitate is formed in a chemical equation, then formation of precipitate is represented by downward arrow mark in chemical equation. Okay, in this example, okay, in chemical reaction, that is zinc, the reaction between zinc and dilute HCl, hydrogen gas is released. Therefore, we will write upward arrow mark here. Okay, this upward arrow mark will indicate the evolution of hydrogen gas in this chemical reaction. Similarly, see here in this reaction, that is reaction between lead nitrate, potassium iodide. Okay, it forms potassium nitrate and lead iodide. This lead iodide is a yellow precipitate. It is yellow precipitate. So here precipitate is formed. Therefore, formation of precipitate is represented by downward arrow mark. Therefore, here we will write downward arrow mark. Okay, like this we have to write the chemical equations. Okay, to write the chemical equations, we should know the chemical formula of the reactants which are taking part in the reaction.